Hey friends, Vincent here. Welcome to Fearless in Rust, where we keep Rust clean and simple. Let's go. Today, we are generating MockTelemetry data in Rust. Perfect for testing dashboards, APIs, or data pipelines before real-world data is available. So now, let's dive in and build it step by step all in Rust. So first, we need to create a utility struct. So here, this is a simple struct, MockDataGenerator. No fields, it's just a namespace utility, very common in Rust for grouping logic. Then, we had the generate mockData function. This function takes three things: a path, which tells us where to write the mock data, a count, the number of telemetry entries to generate, and it returns a result. We use str for path because we only need a reference to a string slice. We are not taking ownership or cloning it. This is faster, zero cost, and idiomatic in Rust. Then we use usize for count because it's Rust's default type for counts and indexes. It's unsigned, so no negative values, and it automatically adapts to your system. 64 bytes on 64-byte machine and 32 bytes on 32-byte ones. Perfect for things like how many telemetry records to create. Finally, the function returns a result to explicitly signal whether writing to a file succeeded or failed. If everything works, we return OK. If something goes wrong, like file permission issues or JSONL Serialisation errors, we return a custom data error. This is Rust's standard way of making error handling safe, clear, and enforced by the compiler. Okay, so now we need to open or create the output file. So, in this step, we use open options to ever create the file if it doesn't exist, or happen to it if it does. Perfect for generating mock data incrementally across multiple runs. Instead of using expect, which will crash the program if the file can be opened, we use map error to gracefully convert the low-level I/O error into our custom file open error. It's more robust and production-ready approach compared to a hard panic. Okay, now next step, we need to add random data with rand and timestamps. So here, we generate new UUIDs for the node and server, so that each data point looks unique and realistic. Now, we will use rand to simulate telemetry metrics like CPU load, memory, battery, or temperature, all with realistic value ranges. This pattern is common when mocking sensor streams, health data, or network stats. Here, genRange picks a random value within a range, perfect for simulating data. Then here, for anomaly field, this line gives us a 10% chance of simulating an anomaly, useful for testing alert systems. Okay, now we need to serialize to JSON health. So we serialize each telemetry struct into a JSON string with set.json to string that turns our Rust data into a text-based format. Then rewrite it to the file with write-ln, adding a new line after each entry, which gives us proper JSONL output, one JSON object per line, easy to stream and parse later. JSON lines is great for logs and big datasets. Each line is self-contained and parsable. Okay, now next step, we need to call the mock data. So, how does this all run in a real Rust backend? So first, the main file. In Rust pools, the starting point is an async main powered by Tokyo. And here, on the lib file, instead of generating mock data there, we delegate to a start function. That's where we load config from environment variables and setup logging. So everything behaves properly across dev, staging, or production. From there, we call start server our main runtime entry point. And inside this function, we have those lines. First, we define the output path, a JSONL file, where each line will be one telemetry entry. Then, we call our MockDataGenerator, asking it to generate 20 fake telemetry samples and write them to that file. Each line follows the JSON lines format, easy to stream, parse, or load into any system that expects time series or event data. So, why do we do this before the server start? Because we want realistic data available before the API or dashboard starts pulling from it. It's especially useful during early dev, CI testing, or when the rest of your data pipeline isn't live yet. And the best part, you can later plug this into a database, stream it in real time, or build an ingestion pipeline, all while keeping the same interface. So, with just 2 lines inside start server, we have integrated MockTelemetry into a real backend flow and made our system testable and traceable from the day one. So now, after running the generator, you will find a file like MockDataGenerator in your project directory. So first, let me start the server. So cd backend, tag, and just cargo run. Okay. And here, a file just generated. So, and here you see we have our 20 lines with node ID, server ID, and all the metrics. Okay, that's all guys for this part. Mocking telemetry data in Rust is fast, realistic, and production friendly, thanks to crates like Rand, Chrono, and Third JSON. Thanks for your time. See you there.